Hello everyone. This is part 2 of homework 28, solving quadratic equations, and we left off with a couple examples where we had to first obtain our standard form of everything to one side set equal to 0, and it's quadratic, we know, because of the squared term. So we see a couple more examples at the bottom here. I'm going to use the little transposition arrow like we talked about in the last lesson and move the 5x and the 50 to the left to join the x squared. So remember, when we transpose and move something from one side of the equation to the other, the sign changes. So this becomes minus 5x and similarly minus 50. Now set equal to 0, and then we continue with our factorization. So pretty straightforward. 1 again, because leading coefficient is just x squared, so we know in each of the binomials just an x and an x. And we have to think of two numbers. Well, let's go for the signs first. I'm going to use trial and error. You can list the factors like we've done in the past, your choice. But I know the signs have to be opposite because the constant term is negative, so one negative and one positive. And then I'm looking for two numbers that multiply to give 50, but combine to give a negative 5. And pull out some scrap paper, just show some guesses again. One's negative, one's positive. Probably a 10 and a 5, right? And let's say if I put the 10 over here and the 5 here, I guessed wrong. I just did this on purpose. Because then we get negative 5x and positive 10x, which combine to give a positive 5x. And we know because we need a negative 5x that we have to switch the signs in the binomials. So instead of x minus 5 and x plus 10, it's going to be, well, the way I've set it up here, x minus 10 and x plus 5. And then we could check. Oops, sorry, you're not seeing my work. Then we could check these. And we do get the negative 5x that we desired. Similarly, you could list the factors. So just one more time showing you this concept. The factors of negative 50. Here there's a bunch of them. 1 negative 50, doubtful. Negative 150. 2 25. 2 negative 25. Negative 2 25. Guess the next ones are 5 and are negative 10, or the negative 5 and 10, and that's pretty much it. So then we could see that the pair that combines to give us a negative 5 is the positive 5 and the negative 10, as we successfully had determined using the trial and error method. So x minus 10, x plus 5. And now we proceed by setting each of those factors equal to 0. That's our 0 factor property. So x minus 10 is 0, and x plus 5 is 0. And so adding 10 to both sides, we get x is 10 as one solution, and subtracting 5 from both sides, we get x equals negative 5 as the other solution. So our two solutions are 10 and negative 5. Now, question 8 is probably one of the more complicated ones that we'll encounter. Notice that it looks like you can use the 0 factor property right away, but you can't because it's equal to 14. And there is no property such that you could set each of these factors equal to 14. This side has to be 0. So in order to deal with this one, I'm going to recopy this. What you first have to do to to obtain standard form is actually FOIL this out. So we get x squared plus 3x minus 2x minus 6, and that equals the 14. And then combining the inners and the outers, we get x squared plus 1x, or just simply plus x, minus 6 equals 14. And now to obtain standard form, we can subtract 14 from both sides. So here I'm going to show it literally subtracting 14, because I've got the like term with negative 6 there, the constant term. And so we recopy the x squared plus x, and now we have minus 20 equals 0, and now it's in standard form. So that one a little bit tricky, because you actually have to recognize that you need to do a little bit of work algebraically to get to the point where we have standard form. But then from there, based on what we've done recently, should be easy. Two binomials, x and an x, opposite signs, negative, positive. The more and more you do this, the more you kind of calculate the inners and the outers mentally. If I put I'm going to go with a 5 and a 4, and if I put the 5 with the positive and the 4 with the negative, that's going to be correct, because the inners give negative 4x and the outers give positive 5x, which combine to give a positive 1x. So at that point, zero factor property, x minus 4 is 0, x plus 5 is 0. Solve these mentally, or show the steps like I'm doing, as I've said many times now. So x is 4, here subtracting 5 from both sides. X is negative 5, and as a summary, x is 4 and negative 5. Okay, so probably won't see that on an exam, but there's at least one of those in the homeworks. And the last page of notes for this section mentions to first be sure to look for the greatest common factor, because the greatest common factor is the first thing we always look for when factoring. Before you do, though, make sure it's in standard form, make sure it's set to 0, and this is. But notice you've only got two terms, and actually there's a cubic, right? So you know something's going on. And if you compare the two terms in search of the greatest common factor, see that a 3 is common. Then remember, between the variables, the smallest power, so x to the first, or just simply x. So if we factor out the 3x, remember here we're reversing the distributive property. So we're asking 3x times what is going to give 3x cubed. We'd need an x squared. And then we have 3x times what will give negative 12x. And 3 times negative 4 is negative 12. And we've already got the x, so that's it. So close up the parentheses, set to 0. But then recognize that what's in parentheses is the difference between two perfect squares, which can be factored. And so the x squared minus 4, perfect square of x squared is x, so x and x. Perfect square of 4 is 2, so 2 and 2. And remember, 1 is negative and 1 is positive. Alright, so now we extend the zero factor property, and we set each of the 3 factors to 0. So 3x is 0, x minus 2 is 0, and x plus 2 is 0. And then solve each one of those. So here we can divide by 3. Certainly you don't need to show that. Here we're going to add 2 to both sides. Again, you don't really need to show that either. So x is 0, x is 2, and then over here we subtract 2 from both sides. So x is negative 2. So Summarizing the solution, 0, 2, and negative 2. Again, separated by commas. Okay, in number 10, we see two terms, but we also should recognize that there is a common factor of x. So greatest common factor of x, factor it out. Again, we're using the reverse distributive. X times what gives 16x squared, or 16x cubed, that is. That'd be 16, and we need an x squared to get the x cubed if we're taking out an x. And then we have the minus, and x times what gives us negative x, and that'd be a negative 1. And then at that point, notice once again that the quantity in parentheses is the difference between two perfect squares. And the hint again is that you only see two terms. It's quadratic because it's squared, and you check to see if the two terms are both perfect squares, and they are. So we set it up. Okay, now in order to get 16x squared, the perfect square is 4x. So we're going to have 4x and 4x. Perfect square of 1 is just 1, so we got a 1 and a 1. And again, one of them is negative and one is positive. So now set each factor to 0. So x is 0. That's actually a solution right away. 4x minus 1 is 0. And set 4x plus 1 to 0 as well. Okay, and these are the two-step process. Again, x is 0 is a solution. Two-step process, add 1 to both sides. Get 4x is 1. Divide by 4. Get x is 1/4. Okay, and similarly here, two-step process, subtract 1 from both sides. 4x is negative 1. Divide by 4. And x is negative 1/4. Okay, so the solutions are, kind of squeeze them in here. X equaling 0, 1/4, and negative 1/4. Okay, so just make sure you realize 0 is part of the solutions. Alright, and here's another. One way you know almost immediately that the greatest common factor is involved is if you see that the equation has a degree. Remember, the exponent is the highest powered exponent is the degree. A degree of 3 or greater. Then you know that you're dealing with something that requires you to first factor the greatest common factor. So, comparing the terms, I see that the only common factor is x. So factoring out an x, we're left with x squared minus 11x plus 30. Set equal to 0. Because remember, we're reversing the distributive. What times x gives x cubed? That's x squared. What can go here times x to give us negative 11x squared? We'd need the negative 11 as well as the x. And what times x would give us 30x, and that's just a positive 30. But then notice that what's in the parentheses is a quadratic trinomial that can probably be factored. And it's an easy one because the leading term is x squared, so the first term of each binomial will be x. And then let's see, I know the signs are both negative, because remember, if the constant term is positive, signs are the same, and they will be whatever the sign of the middle term is. So in this case, both negative, and it looks like a 5 and a 6 will work. And you could check that, or use the factor method, whatever you prefer. But then each factor is set to 0, so x is 0, x minus 5 is 0, and x minus 6 is 0. And the x is 0 is a solution already. Here we'll add 5 to both sides to get x equaling 5 is another solution. And here we add 6 to both sides to get x equals 6 as a third solution. So x equals 0, 5, and 6. And one thing to notice about these three examples, they were all third degree equations. They were all cubic, right? With x cubed in each of them. And notice that we have 3 solutions for each of them. Okay, so something to consider as a general rule. Now, we're not going to give you too many cases like this, but I threw 1 or 2 in the homeworks, and when you move on to Math 110, certainly you're going to see a lot more factorization. This is the case where the leading coefficient is not 1, and there's no greatest common factor. So that's when we need the true trial and error method to complete the factorization. Or we could use factor by grouping, which is something that you either use one or the other. And I showed you factor by grouping before, and I'm going to choose to use the trial and error. So first note that it's quadratic because the squared term. Secondly, it is in standard form because it's set equal to 0. And thirdly, that there is no common factor and the leading coefficient is not 1. So when we set this up for the factorization, we have to force the first terms to give us 2x squared. So it's no longer just x and x, it's going to have to be a 2x and an x. Let me pull out some scrap paper for this and make some guesses. Now, fortunately, this constant term is the number 3, which leaves us with only 2 choices. Either a 1 and a negative 3, or a negative 1 and a 3. So, make a guess. Let's say I put the 1 over here and made it positive 1 and a negative 3 over here with the 2x. That would give, so guess and check, right? Trial and error. Negative 3x for the inners, positive 2x for the outers, negative 1x, which is not correct. And it's not even close because it's a negative 1x, we want a negative 5x. So changing these signs will not help. So the only thing that will help is the placement of the 1 and the 3. Instead of the 1 going with the 2x, let's put the 1, I'm going to make it negative just to reinforce the concepts. I'm going to put the 1 because I know what it is. So I'm going to put the 1, switch them around, we get negative 1x, positive 6x, combined to give positive 5x. But see, we're looking for a negative 5x. We're good with the 1 and the 3 in those positions, but we just have to switch the signs. In other words, instead of, sorry, I was writing that without you seeing it, so I'll give you a second to catch up. But in other words, instead of 2x minus 1 and x plus 3, it's going to be 2x plus 1 and x minus 3. And then we could check just to verify that we get the negative 5x's we were looking for. Okay, so 2x plus 1 and x minus 3. Alright, and then we set each factor to 0. So 2x plus 1 is 0, x minus 3 is 0. Okay, this is our two-step process. First subtract 1 from both sides, 2x would be -1, then divide by 2, and x is -1/2, and then here just simply add 3 to both sides, and we get x is 3. So summarizing the solutions, x is -1/2 and 3. Okay, so this one even a little bit more tricky because there's more combinations. And for example, you could use a 2x when you set this up. You could use a 2x and a 2x and then exhaust all possibilities. But I've done that already on my own, so I'm just going to cut to the chase and do a 4x and an x. Okay, so see, if you did do a 2x and a 2x, we know the signs are going to be opposite, positive and negative. Probably going with a 7 and a 5. And we get positive 10x and negative 14x. Nowhere close to the 23x we're looking for. And then the only other factors of 35 are 1 and 35. And if you put a 1 in here and a 35 in here, or vice versa, here, let's just do it for the sake of it. We get 2x and minus 70x, so way off, minus 68x. So those are no good. And see, it won't help switching the 1 and the 35 or the 7 and the 5, because the first terms are weighted the same. They're both weighted at 2x. So then that leaves us pretty much no choice but to go with the 4x and the x. And again, signs are going to be opposite, so one positive, one negative. And I'm going to go with the 7 and the 5. Now, if I put the 7 with the 4x and the 5 with the x, that gives 7x and minus 20x. So we'll get minus 13x, so that's no good, because we're looking for a positive 23x. But now I could switch the 5 and the 7. Make it 4x plus 5 and x minus 7. See, because the whole idea is that they're weighted differently, the 4x and the x, as opposed to like just a 2x and a 2x or an x and an x like we typically do. So this gives positive 5x and negative 28x. Alright, there we go. That's negative 23x. I know it's not exactly what we're looking for, but we've experienced this enough to know that we're just going to switch the signs. So instead of 4x plus 5, it's 4x minus 5. And instead of x minus 7, it's x plus 7. And I'll let you check that on your own. So then finally we set each factor to 0. So 4x minus 5 is 0. X plus 7 is 0. Here's our two-step process. Add 5. We get 4x equals 5. Finally divide by 4. So x is 5/4. And here just simply subtract 7. Alright, so summary of the solutions. X is 5/4 and negative 7. Alright, so that's it for homework 28. And then we just have homework 29, which are basically just word problems, applications of quadratic equations. And then that'll be it for our 5th exam. So we'll see you for homework 29 when you are ready.